Welcome to Mathmaxtra. This is Saritha. Today we are going to learn tangent properties. So we have seen what is a tangent in the yesterday class, and now we will discuss what are the different properties of a tangent. Okay, the first property is you take one circle and you draw one tangent. This is a tangent of a circle. Okay. So this tangent of a circle is always perpendicular to the radius through the point of contact. Means if you draw radius through the point of contact, means like this. This radius is always perpendicular to the tangent line. Yes, this is always perpendicular. This is the center of the circle and this total is the radius of the circle, and this we call it as a point of contact P, and this is a tangent line. Okay. So what is the first property? The tangent of a circle is always perpendicular to the radius of the circle through the point of contact. Okay. So if you take this tangent here, what happens? See, if this is a tangent, this is a tangent line and this is the point of contact, isn't it? So through this point of contact, if you draw a radius, and this here also, this is perpendicular, means this tangent line is perpendicular to the radius of the circle, isn't it? So wherever you take a point, means where the tangent meets the circle, the point of contact, there the tangent line is perpendicular to the radius. Okay. Second property is you take one circle, you consider any two parallel tangents, means the two tangent lines must be parallel. See, if these two are tangent lines, if these two lines are tangent lines of a circle, and this is one point of contact and this is one point of contact, and these two lines are parallel tangents. So the distance between these two parallel tangents always be a diameter of a circle. See, in order to find the distance between the two parallel tangents, we must join the two point of contacts. Yes. If you join these two point of contacts, what happens? See, this is the center of the circle and this is radius and this is radius and this totally diameter of a circle, isn't it? So that is why the distance between the two tangent lines is always a diameter of a circle. Okay. Third property is, if you take a circle, this is a circle and this is the center of the circle. Okay. So if you join the center of the circle to any tangent line, means if you draw any tangent, means you can draw tangent here, 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 anywhere you can draw one tangent, right? So if you join the center of the circle to any tangent, if this is a tangent, if you draw a perpendicular line joining the point center of the circle to the point of contact, this will always be equal to radius of the circle. Did you understand? See, if you draw a perpendicular from the center of the circle to the any tangent, center of the circle to the any tangent means to the point of contact. So this perpendicular distance is always equal to radius of the circle. Okay. Our next property is, see, if you take a circle, how many number of parallel tangents can be drawn to a circle? Means in order to be a parallel tangents, the distance between those two parallel tangents must be equal to diameter, right? So at max we can draw two parallel tangents, isn't it? Means the number of parallel tangents can be drawn to the circle is at most 2. Why we are saying at most 2? Why can't it be exactly 2? See, if you consider a point circle, how many parallel tangents can you draw? If you draw one line, yes, only one parallel tangents can be drawn. That is why the number of parallel tangents can be drawn to the circle is at most 2. Means maximum 2. It can be 1 also. Okay. Now we will discuss what is a length of a tangent. Length of a tangent. So how to define length of a tangent? See, if you take one circle, I am taking one external point. This is a point P. So I am drawing tangents through this external point to the circle. How many tangents can we draw through an external point? We can draw exactly 2 tangents, isn't it? See, I am drawing 2 tangents. Yes, these are the 2 tangents, and this is the point of contact A and this is a point of contact B. So how to define length of a tangent? The distance between the point of contact to the point through which the tangent is drawn. Yes. So this we call it as a length of a tangent. Yes, this PA is a length of a tangent. And similarly, if the B is a point of contact, the distance between the point of contact to the point through which the tangent is drawn, means this distance we call it as a length of the tangent PB. Okay. Now we will find this length of the tangent. Okay. This is the center of the circle. Okay. And if you join the center of the circle to the point of contact, what happens? This will become a radius of the circle, right? Isn't it? And here, just now we have discussed one property that the radius of the circle is always perpendicular to the tangent at the point of contact, isn't it? So this is always perpendicular. And similarly, if you draw center of the circle to the other point of contact, here also same thing happens. This is a perpendicular, this radius, this is the distance from the center of the circle to the point of contact. This is the radius of the circle, and this radius of the circle is always perpendicular to the tangent PB. Yes. Okay. And I am joining the point to external point P to the center of the circle. So I don't know this length. That is why I am considering this length as a d units. Okay. Now I am trying to find out this length of PA, which is nothing but length of the tangent. Okay. Now you see this PAC is a right angle triangle, isn't it? So what we have? We have one property in the right angle triangle that hypotenuse square is equal to sum of the sides squares. Yes. See, if you write like that, you observe this is a right angle triangle. So what is the hypotenuse in this? So yes, these two are perpendicular, means these two are sides, isn't it? And this is the hypotenuse. Okay. So we have a relation that hypotenuse square, which is nothing but d square, is equal to sum of the squares of the sides, right? So one side is the length of r units, isn't it? So r square, and another side is nothing but the length of the tangent, which is PA, isn't it? So PA square. But we want to calculate PA. So PA square is equal to, you take this r square on left side, which is nothing but d square minus r square. Okay. So PA is simply under root of d square minus r square. If you know the distance between the external point to the center and radius of the circle, you can easily find out the length of the tangent. Okay. And similarly, if you find out PB also, so you try to see, this is a hypotenuse. See, as these two are perpendicular sides, this PB and the radius, and this is a hypotenuse. Similarly, So what happens? D square is equal to R square plus PB square. See, in place of PA square, you write PB square. So you will get PB is also equal to under root of D square minus R square. From this, what we can conclude? If you draw tangents through an external point, the lengths of the two tangents is always equal. Means the length of these two tangents are always equal. Okay? Through any external point, not only this point, you can consider point here or here or here. You can consider point anywhere. But through that point, if you draw two tangents, those two tangents lengths are always equal. Okay? Our next property is, you observe this PAC triangle and PBC triangle. How they look? So you observe as this PA is equal to PB, because just now we have seen the property that the lengths of the tangents drawn from an external points are always equal. Yes, these two are equal, and this is a common hypotenuse for this triangle as well as this triangle. Yes, this is also equal, and this side is also equal because both are radius only. Yes, so according to the axiom side side side, what happens? If the three sides are equal, automatically three angles are also, that means the corresponding angles are also equal. Corresponding sides are equal as well as corresponding angles are equal. We can say that these two triangles are congruent to each other. Okay. So which is nothing but the triangle PAC is congruent to the triangle PBC, which is nothing but the angle P in this triangle is equal to the angle P in this triangle, which is nothing but this is a angle P in PAC triangle. Okay, and this angle is a angle P in PBC triangle. So these two are equal, isn't it? So by this, what we can conclude? We can conclude that if you join, means the line joining the external point to the center of the circle always bisects the angle between the tangents. See, these PB and PA are tangents, right? This total angle is the angle between the tangents. Okay. So this angle, this PC line segment bisects these angle between the tangents, means these two angles are equal. Okay. So if I consider these angles are x degrees as these two are equal, what happens? See, this is x degrees. This is 90 degrees, 90 degrees. And so what about these? These two angles are also equal, right? As these two triangles are congruent to each other, the corresponding angles are also equal. So these two angles are equal, these two angles are equal, as well as these two angles are equal. Okay. Our next property is, see, this PACB is a quadrilateral. You can easily observe. Okay, PACB is a quadrilateral. And see, that quadrilateral is formed by the tangent through the external point and the two radii. Yes. So these are PA, PB, BC, AC are the sides of the quadrilateral, and this quadrilateral is always a cyclic quadrilateral. What is cyclic quadrilateral? A quadrilateral means the circle must pass through the all vertices of a quadrilateral. Then we call that quadrilateral as a cyclic quadrilateral, isn't it? Means if you draw a circle, like this, yes, if you draw a circle, these, see, if you draw a circle through the all vertices of this quadrilateral, those four vertices are lie on the same circle, then we call this quadrilateral as a cyclic quadrilateral. And we have a property in the cyclic quadrilateral that this B and A are opposite vertices, right? See, you consider PACB is a quadrilateral. This B and A are opposite vertices. So at angle B we have 90 degrees. At angle A we have 90 degrees. What is the sum of these two? Means which is angle A plus angle B, which is equal to 90 plus 90, 180 degrees. isn't it? And similarly, if you consider angle P and angle C, this will also, the sum of these two angles are also equal to 180 degrees, because in a quadrilateral, the sum of all interior angles of the quadrilateral equal to 360 degrees, right? Then we have this sum is equal to 180 degrees. What is the remaining angle left, which is equal to 180, right? So these two angles must be equal to 180, which is nothing but angle P, means the total angle APB angle, means the P is nothing but angle APB. So this angle P plus this angle C, which is nothing but ACB angle. So angle C, which is also equal to 180 degrees, means this PACB is a cyclic quadrilateral. Our next point is, now we are going to calculate the area of this quadrilateral, which is nothing but the quadrilateral formed by the two tangents and two radii of the circle. So we are going to calculate area of this quadrilateral. See, just now we have seen that this PAC triangle and PBC triangles are congruent to each other. Means if you find out the area of one triangle which is equal to area of the other triangle, means the area of these two triangles are equal. Okay. Now I am trying to find out area of one triangle. That is more than enough to find out the area of a quadrilateral, isn't it? So what is the area of a quadrilateral PACB, which is nothing but, so this is one triangle, this is one triangle, which is nothing but 2 times of the area of triangle PAC, because both areas are equal. That is why I am writing 2 times of area of a triangle PAC. So which is nothing but, what is the area of the triangle PAC? As this triangle is a right angle triangle, what is the area? Which is nothing but simply half times of base into height, right? So what is the height in this triangle? So this is a perpendicular length, right? So PA, this PA is the height of the triangle. Yes, PA is the height of the triangle, and this is a base of a triangle. Yes, this is a base of a triangle, which is simply CA, isn't it? Now simply, which is nothing but PA into CA. What is PA here? This is nothing but length of the tangent, isn't it? This is the length of the tangent, and this CA is what? Radius of the circle. Means if you know radius of the circle and the length of the tangent, you can find out the area of a quadrilateral formed by two tangents and two radii. Yes. So this is simply a product of a length of the tangent and a radius of the circle. Okay. Now you tell me, what is the length of the tangent which is drawn from the point on the circle? Means we have three cases, right? We can draw tangents from an external point to the circle, and we can draw tangents from the point on the circle and the point which is interior of the circle. So from the interior of the circle, we have seen that we can't draw any tangents. Okay. So through the exterior point, we have seen some cases. So what happens if the point is on the circle? If you want to draw a tangent through this point, so what is the length of a tangent? So length of a tangent is nothing but what we have seen, the distance from the point of contact to the point through which the tangent is drawn. So here what happens, both the points are coincide, which is nothing but the length of the tangent is always equal to 0, isn't it? So if you draw a tangent through a point on the circle, then the length of the tangent is always equal to 0. Okay. See, this is a circle. Now I am considering one interior point of a circle. So what is the length of the tangent drawn from this point? As we can't draw any tangent through the interior point of a circle, so the length of the tangent does not exist. We can't even say it is 0 units. See, if the point is on the circle, we can say that it is 0 units. If the point is interior of the circle, we can say that the length of the tangent does not exist. Okay, these are some different properties of a tangent, and we will discuss next topic in the coming video. Thank you.